basically the CA can generate a key for you as well if you like. So let's have a look at how it looks like. Okay, so basically I've skipped some of the parts, but this is the basic process that the user goes through. So he can choose a certificate profile, which will decide how his certificate will actually look like in the end, what extensions are set, stuff like this. Then he can select the type of key generation, which was what I already talked about a bit. So you can do browser-based, PKCS10, and so on. Then, of course, you have to set the name of the certificate, which is basically the subject of the certificate. Here you can see, if I get the pointer, here you can see that, of course, you can configure this to set your organization, for example. So basically, you want to have all your certificates contain your organization if you deploy it somewhere. So what else can you do? You can always set subject alternative names, which is something that is not as widely used as I guess it should be. Something like when I look at server certificates, or self-signed server certificates all around the web, especially in the chaos area, all these are signed for *.blahfasel.de. So there are actually subject alternative names where you can put your DNS names of the real machines. Of course, you have to be, you don't have to be lazy, so you have to put all the DNS names in there, but you can do that. And it would be pretty helpful because that would be one less browser warning you get. So basically, that's like HTTP 1.1 is compared to HTTP 1.0, subject alternative names to no subject alternative names. So that's my little rant about subject alternative names. Use them more. And of course, if you use OpenXPKI, you can get them for free, as you see. And this is what you see if you use the SPKC-based request. So basically, you can just choose the key length here, which is a built-in dialog from Firefox here, and then your key is being generated on your browser. Also, it says that this might take some minutes. This only takes some minutes if you've got really, really, really slow hardware. So this is really fast, and then you've got a certificate request, which is sent to the CA, and then all the fun starts for the CA side. But basically, at the browser side, you're nearly finished, and you just have to wait for the CA to sign your certificate, and then, well, you can install your certificate, and it will be in your browser store, and you can export it to PKCS12 or do whatever you like with it. So that's really nifty that you can do it all within the browser. Okay, so how does this look like? Okay, I expect nobody to be able to read this. It's just for the structure. So this is how the workflows actually look like. Like Michael already mentioned, this is basically a state machine. So you've got... Okay, I'll try. But the mic keeps going down there, so that's a bit annoying. Okay, maybe this is better now. So basically what you have is you've got states, which are these small boxes around here, and you've got activities, which are the things in between. So you can move from one state to another with an activity, and you can only do this if a certain condition is met. So what else is there? Something that will be in pretty much any workflow, or not in any workflow, but in many workflows we have is the approval part here. So you can see a bit more detailed in what is going on here. So basically you can approve CSRs, and you can cancel the approval. You can reject the CSR, you can reject it from here as well, and basically you can have as many approvals as you like, and you can configure how many approvals you need, or how many approvals you need for a certain type of certificate. So if, say, somebody applies for a CA certificate, you probably don't want, like, okay, somebody clicks approve, and then he has got a CA certificate. So you can actually decide how that is checked, and you've got the condition here for the check CSR approval. So basically, the CSR can only move out of the approval state if, well, all the conditions are met that you specify in the condition class. So, well, down to the core a bit. This is how it looks like in the XML configuration. Well, basically, except for it being XML, I think it's pretty much readable. I mean, you've got states here, you've got actions. Well, basically, they are called actions because that's what the name in workflow, the Perl module we are using is. We call them activities, and we've got conditions. So basically all you can see here, these are symbolic names, and they maps to some kind of Perl class that actually executes the activity or checks the condition. So this is actually how it looks like in Perl in an activity itself. So you just have an execute sub, and then you can have a context. So every workflow has a context where the data concerning this workflow is stored. And you can, of course, modify the context to retrieve some data from the context, store it into the database, and write something back into the context. So this is pretty useful from the abstraction kind of view. So you basically deal with the workflow context in each step, and you modify it, and then you end up at a different state, and you can do something else, and you can move on. Okay, well, so much for workflows right now. I guess that pretty much covers it from the top to the bottom. A bit about SCEP. So, SCEP. SCEP, well, I just make a quick check. Who has ever heard about SCEP in this room? More than I would have thought. Okay. For those who don't know, SCEP is the Simple Certificate Enrollment Protocol. It's currently an IETF draft, which has been initiated by Cisco. So they were the driving force behind that. Currently, it's expired. I think it expired on December 2nd or so. There's not a new version yet, so if you really want to read it, you have to use the Google cache. That's a bit annoying. And basically, it's a protocol to automatically enroll for or renew certificate. So if you have like an embedded machine, a router, a VPN gateway, something, it might need a certificate, how to get it on there. So basically, this is what SCEP is about. SCEP can talk to the CA and say, okay, I'd like to have a certificate, please, or my certificate is running out, I have to get a new certificate. So how does it look like? Basically, well, it's PKC is 10 wrapped and PKC is 7 over HTTP. As said, so it could be worse. I mean, people could have gotten worse ideas. Basically, one of the things that's a bit annoying is that the error codes are a bit nondescript. That's one of the bad things about the protocol. But all in all, I guess it's a pretty decent protocol. Yeah, and it's implemented in many hardware devices, not only by Cisco, but by lots of other people as well. So basically, even though it's a draft, it's pretty much ready for production. All the people are using it already. So why are we doing it, actually? Why do we want to have it? Well, the alternative is doing it manually, which is, well, not an alternative, actually. So you have to request a certificate. So, for example, you have to use the web interface. Somebody has to get the certificate from there and, well, install it on the device. Note the expiry date somewhere in a calendar, maybe a digital calendar, maybe like even a paper-based calendar. And then, yeah, you have to already remember that you have to request a new certificate come the expiry date, or preferably before the expiry date. And you have to install that again. So you have to repeat that. You have to don't miss mistakes. And if you have got a lot of machines, that's basically not practical. So it's pretty unsuitable in larger installations. Okay, so I'm going to talk about a bit how it looks like from the user perspective. I'm afraid that might not be really readable. It's not really that important that you can read all the details. Basically, what I'm talking about is SSCEP, which is the standard Unix tool for speaking SCEP. There are some more free software tools that can do that. Actually, there's one Java-based tool, but I don't know anybody who's ever gotten that to run because it's based on a really, really old Java version. So if anybody of the people who just raised their hand on SCEP has gotten Java SCEP to work, I'd be really interested to know. So basically, what do? First of all, you get the CA certificate from the SCEP server, and of course, then you verify the fingerprints out of band, please. Because, I mean, otherwise somebody might just sneak an SCEP server on your ass. So you have to do that. And then you can just send your CSR to the CA. Basically, you generate a key, for example, using OpenSSL, and you generate your PKCs 10, and you pass it into SSCEP, and SSCEP sends it on to the CA. Well, you have to wait for the approval, so you get a pending response back, which makes fine with our workflow module. So basically, the workflow we start here is then in state pending as well. And if something happens, then it might end up in state success, which is when you are done, you get the certificate back, the certificate is installed. Okay, more scary workflow pictures. So this is how the SCEP workflow looks like. Actually, it just looks scary from the outside. If you actually wanted to implement it, that's how we started. We just drew the picture of, okay, what happens in which state, and how do we decide if this is a renewal or not, and stuff like this. So it's actually pretty nice to design it that way, and that's what we did. And then we put it into an XML file. We printed that out, and we drew some more lines. Well, we have to change that and this, and that's pretty nice about using workflows here. And the good thing is that we can reuse stuff as well. Well, this looks familiar. Well, maybe not from that point, but from here, it's the same approval code as before. Because basically, you might want to have an approval in SZAP as well. So we can just use the same code here, or we're using the same configuration as in the normal certificate request file. So that's pretty useful. You can see a bit about workflows are useful for actually reusing code, or actually reusing configuration. Okay, shortly a bit on alternatives. Nobody actually wants to do that, I guess. PKIX CMP is the certificate management protocol, which has actually been standardized in RFCs, but it's not really in wide use. The only people I know of that have implemented that are actually the Baltimore people who are, well, you heard it, gone. And the Novosec people have implemented in their bouncy Castle Java cryptographic service provider. So that is actually being used by another open source CA project. So these are the only people who have actually ever implemented that stuff, because it's really, really complicated, and it covers all the certificate management issues, not only applying for a certificate. So the other thing that is there is CMC, which is certificate management over with cryptographic message syntax, which basically is a superset of PKCS7, and it's used in S-MIME as well, or it comes from S-MIME. It's standardized as well, and well, the problem is that there's no transport defined. So basically, somebody just chooses the transport, and of course, Microsoft just chooses COM-DCOM as a proprietary transport, and well, that sucks a bit. Because we would really like to see support for that, because that would be just easy to replace a Microsoft CA for domain controller enrollment, because the domain controllers are just enrolling using that protocol, and you could just stick a box and say, okay, this is our open source replacement for Microsoft CA. That would be really neat. So basically, the protocol is pretty nice, and it could be implemented. The problem we are having is the COM-DCOM part, which free libraries for COM-DCOM are a bit, well, scarce, I guess. So what else is there? I was talking a bit about automation as well. We can do SZAP automatically even much more with a little helper program called CertNanny, which is another open source program, kind of a sister project. And the idea is basically you install the program and you forget that you ever have to re-request certificates, because you could just run it in a cron job, and if your certificates run out, it just runs out and says, hey, I have to request a new certificate via SZAP, and I can modify the key store. So basically, it's available on a lot of platforms, some really weird ones as well, and more weird ones coming along on the way. You can modify OpenSSL keys, PKCSH, Java key stores, GSKit, and a certificate store. So that's pretty much nearly everything everybody uses, actually. PKCS12 is missing, I guess, but more or less this covers a lot of software that actually uses certificates. And it's widely deployed within a large financial institution. That's basically everybody who ever gets a certificate for a server. We just ask them, have you ever installed CertNanny yet? And if they say no, we just say, why not? Because it will solve all your problem. And well, basically, you don't run into a situation where your certificate expired and you call us and you say, well, everything is going to hell. Because that actually happens sometimes. Not only within the organization, but with other organizations as well. Okay, next topic, a bit about smart card personalization. What do we need smart cards for? I guess you all have got ideas for what we need them for. What, well, our customer actually needs them for, what the ideas there are is smart card logon, well, a bit boring. Wireless LAN authentication, which is pretty neat, I guess. You can do the authentication using a smart card. And the most important topic here, or the most current topic, is file server encryption, because, of course, you're doing outsourcing. Of course, everybody does outsourcing, you give away your file servers. This means you're giving away your data, which is a pretty bad thing, especially if you give away your controlling or your human resources data.